Good morning, students. And now we are going to see the problems which are based on um, PMI, that is principle of mathematical induction. Okay, so how to prove matrices statement problem by using PMI we are going to see now. That is, you look at this question. If A is equal to this matrix, right, then prove that A power n is equal to 3 power n minus 1, 3 power n minus 1, like that. Okay, and for all n belongs to capital N, where capital N is a natural number. So when you see like this questions, for all natural numbers belongs to n belongs to capital N, then there's this sort of problem you can prove by mathematical induction. It's a 11th standard concept, right? So what is the mathematical inductions steps, or shall we recall? What is step number 1? Step number 1 is yes. Step number 1 is you need to prove the statement for n is equal to 1. You need to prove the statement for n is equal to 1. Okay. Next step is what? Step number 2 is what? This is step 1. Step number 2 is you need to assume the statement is true for some number k. You have to assume the statement is true for some number k. You have to assume. Third step is what? What is the third step? Yeah, you need to prove for, right? Step number 2 is just an assumption. Step number 3 is you need to prove for the statement is true for n is equal to k plus 1, right? For that you have to prove it. Okay, step number 3 is you have to prove. Step number 1 is you need to prove. Step number 2 is you have to assume, right? These concepts and all, already we discussed in 11th standard, but with the matrix, right? How to do sums, right, when the matrix is given. Okay, so we'll start now. So what you have to prove here? You need to prove that, right? PT means prove that a power n is equal to this one, right? So step 1 for n is equal to 1, right? So n is equal to 1 is left hand side. You take LHS is n is equal to 1 if you take, right? That is a power 1 you will get, because a power n, no. So n is equal to 1 if you take a power 1. A power 1 is a as it is. Okay. Then RHS, right hand side. Over here, substitute n is equal to 1. So n is 1. If you substitute 1 minus 1, it will become 0. So here fully 3 power 0, 3 power 0, like this. Okay. Next, what you get? 3 power 0 is what? 1. So everywhere 1, 1, 1, 1, 1. This is nothing but the given matrix. Correct? That is A. So you look at this one. Left hand side and right hand side both are A. So both are same now. Therefore, the statement is true for n is equal to 1. So we are proving that the statement is true for n is equal to 1. Okay. Now is assumption. What is the assumption here? You need to step 2. Step 2 is assumption. You need to assume a for n is equal to k. It is true. You have to assume. Okay. So replace all n by k here, right? So a power k, 3 power, instead of n, k minus 1. Okay, like this. So this is both are equal. Left hand side and right hand side are equal. You have to assume here. Okay. So we assumed. Next step, third step is you need to prove. To prove for n is equal to k plus 1. Wherever n we got over here, over there, you need to put k plus 1. Okay, so here n is k plus 1. If you put k plus 1, minus 1 will become plus 1 minus 1 will get cancelled, and you get only k. So that is what this one, 3 power k, 3 power k, and 3 power k here. But you see this one you have to prove it. This statement you have to prove. For n is equal to k plus 1, you have to prove. So how I am going to prove? By taking the left hand side. So the LHS is nothing but this one, a power k plus 1. That a power k plus 1, I can write it as a power k plus 1. I can write it as a power k into a. Okay, easy, no? a power k plus 1. No, I can write as a power 1 into a power k. So a power 1 is nothing but a. That matrix is the given matrix. This one is a given matrix. That matrix I'm substituting over here. Okay, and a power k is step 2. Step 2 is your assumption, right? That assumption in that a power k is what you know. That matrix you are going to substitute here. Now multiply both row into column. If you multiply both the matrices, so I will multiply row into column, row into column, row into column, like that. So first row, first column will give first element, correct? So first row and first column, if you multiply, you see 3 power k minus 1, here also 3 power k minus 1, and here 3 power k minus 1. So 3 times 3 power k minus 1 you will get. That's a first element, correct? A11. Okay, so this is 3 times 3 power k minus 1. So now here 3 into 3 power k minus 1, powers will be added. When the bases are same, powers will be added. So if you add, what will happen? It becomes plus 1 and minus 1 will get cancelled, because 1 plus k minus 1. So plus 1 minus 1 will be getting cancelled. Remaining will be 3 power k. So first row and first column, if you multiply, you get 3 power k, correct? So 3 power k is over here, I entered. Okay, second row, second column also same matrix, same element, only 3 power k only you will get. So every element will become 3 power k, 3 power k, 3 power k. So this is actually equal to what, you know, it is equivalent to the RHS, you see. So you proved it. Where you started LHS, you started, and you proved the RHS. That means the above statement is true for, right, n is equal to k plus 1. Therefore this mathematical statement, which mathematical statement? This mathematical statement is true for, I mean P of n is true for all n belongs to capital N. Okay, so that's all about this problem. So this is how you need to do the sums based on matrices, as well as you can prove that those sort of problem by PMI once if they have given for all n belongs to capital N, right? If they are not giving this statement, then you should not do by PMI. Okay, I hope you have understood. Thank you, students.